So we're, as you said, we're based in the north of England, northeast of England at Durham University. And we run a part of the DiRAC national facility, which is an HPC facility. And our primary focus here in Durham is on cosmological simulations, black hole mergers, things like that. So we're funded by a particular research council, with Science and Technology Facilities Council, and their remit is astronomy, cosmology, nuclear physics, and particle physics. So everything we do, well, most of the things that we simulate in our system is within that topic areas. So we have we're actually, I think, the largest HPC system, certainly research system in the northeast of England, and we have about 50,000 cores of compute. And in terms of storage, we're running several generations of Lustre file system at the moment. In fact, four generations. So we range from systems that are about a petabyte in size up to a system that's coming online that will be, when it's fully integrated, will be about 10 petabytes in size. And what we do with these systems is the way that our typical workflow it runs is we run a long simulation that's simulating, say, the universe. So it starts with the Big Bang and propagates that forward in time. And the idea here is we want to be looking at the simulations and seeing how well they match to what we really see in the universe when we look with telescopes up into the sky. And by tweaking some of the physics in these simulations, by fine-tuning the amount of dark matter and dark energy and things like that, we're able to match our simulations better and better to what we actually see in the real sky. Now this produces, as you can imagine, large data volumes. So the universe is not small. And particularly as we have to store many time steps of this, which correspond to different redshifts, so looking back in time. So we store all this data, and then we run these big simulations, and then we can spend the data can then be valid for years, in some cases a decade or more, and we continually look at this data, analyze this data, and get as much out of it as we can. And so these large data volumes that we have, then you generally look to try and archive them onto tape to keep them safe. And we use the Atempo Miria to manage some of these workflows. So moving data from tape, from disk to tape, and then back from tape to disk, and so on. Yeah, so we have large cosmological data sets. These are simulations that we've run that then we need to store the outputs of these simulations for further analysis. So we have large amounts of data there. We also have many users on our system. So it's an international system. It's used by people worldwide. And so they all have their own codes, their own software stacks and things on the system. So what we were looking for a few years ago was a way that we could do several things. We wanted to have a secure way of backing up the data. So for particularly the what we call the home space data. So their source files and things like that, so we wanted some way of making sure that if they deleted their stuff by mistake or there was a disaster with the file system, we had a way of restoring their data from a very recent period in time. We were also looking at more long-term data curation, so a long-term archive of some of these cosmological data sets. And some of the systems that we had been using were getting a bit old, were not supported anymore, and of course with that comes a risk of not being able to restore hardware if things break and so on. And so we were very interested in the Atempo solution, and so we started working with Atempo to see how that could meet our needs. And basically what we do now is we use the Atempo Miria software to not only back up our home space, so that user source files and small things are kept safe. So we every night we're able to back up their home space with that, but we also then are able to use a large tape archive to archive these large cosmological data sets. So one of the things we have as a DiRAC as a whole have recently been through a large procurement, and the DiRAC system up at Edinburgh University are now, they're just bringing online an Atempo solution. And this now that we've got Atempo at multiple sites, it potentially gives us the ability to transfer data using the Atempo data movers rapidly between sites, to explore data on tape systems at different sites. We've previously run the proof of concept with Cambridge and Leicester sites, where again, they've archived data as part of this trial. They've archived data from their systems to the tape library in Durham, and that's worked very well. So as we move forward, one of the things that we potentially might consider is looking at how we curate this data, which is multi-site data, how we make a better job of curating this data using the tape libraries that we have. So not all the sites have tape libraries, for example. How we can use this, how we combine it, and also move data between sites to where researchers require it. So, for example, large simulations might run here in Durham. Some of that data may then be required for analysis in, say, Cambridge. And so we need to look at efficient ways of moving that data between Durham and Cambridge, and using the Atempo Miria data movers is one potential way that we're looking at doing this.